Hey guys, Technivorous here. First off, sorry about my voice. I have a little bit of a cold. It's not stopping me from making videos, but I do sound a little bit funny, so I apologize for that. Alright, today I'm going to show you how to print quality PETG parts on your Ender 3 or other 3D printer. We will be using a couple different PETG brands to print several components for this assembly. Now, this is a vise I found on Thingiverse, and I'll put the link to the thing down below. And while we're on the subject of links, the other link in my description is to my Cura's profile page, where you can find my Cura PETG profile for the Ender 3, among my other profiles, for free download and use. The PETG profile is ready to go and will work for most PETG right out of the gate, as I'll demonstrate in a minute. Now this video is longer than most of my others. I've had a lot of questions about PETG, so I wanted to go a little bit more in depth. There's a lot of information here, so I suggest you watch the whole thing once before skipping around, because there's a lot to see. In our work today, we will be using three different PETGs. We will use a transparent sea green from filaments.ca on the base and sliding jaw. We'll use some E-Sun blue for the faceplates, and finally an MG Chemicals red for the knobs and gears. We'll be using two different slicers as well and discussing the settings for each. Because you see, not all PETG is created equal, and it's important to note that even in a perfect PETG profile, we will need some adjusting based on the particulars of the filament itself. For example, most PETGs with high translucency, such as E-Sun filament we will use, require higher temps than, say, the red from MG Chemicals, which is completely opaque. In fact, before we look at my settings, let's look at the recommended settings for the filaments.ca PETG. So, this is a handy website on the filaments.ca side of things that pretty much breaks down the requirements for a bunch of kinds of filaments. So, what we're going to do, if I can get my internet to load here, is take a look at this page, because there is a specific section on PETG, and since I'm using their PETG, I thought it would make sense to kind of check out what they recommend. Now, if you look here, this is a handy guide. There is a whole list of different kinds of filament. Now, if I were to click on one of these, it will tell me the best settings to run to use them. Today we're going to do PETG, so we'll click on that one. And hopefully it'll bring us down into the chart here. Alright, so here we have the settings. Let's take a look. Right off the bat, we notice it says the range should be between 230 and 250 degrees C. Remember that, at least 230 C. Next, let's look at the particulars. Set the bed to at least 60 degrees. Check. No problem. Spool of filament.ca PETG I'm holding actually states the bed should be between 75 and 85. Since this is indicated on the spool, we will use this setting instead of the generic recommendation of 60 or higher. Now pay attention to the next bit. To get the optimal print temperature, start from 230 C and continue to increase the nozzle temperature until the print starts to brown regularly. From that point, drop the temperature by a couple degrees and make a note of that temperature. Basically, this is saying you want it as hot as you can get it without burning the filament. So in order to find that temperature, you're going to burn the filament and then turn it down a little bit until it's no longer burning it, and that's your sweet spot. Next, the guide recommends printing on PVA mixed with water in a specific ratio. I'm printing on PEI myself, which I highly recommend. If you want to, you can certainly try a PVA mix, but I can tell you painter's tape works just as well. Just don't forget to level the bed after applying tape, as it adds height to the bed. Then we are told no cooling is required during the print. This means the part cooling fan, and I'm going to turn mine off on the Ender 3, but I don't advise running your Ender 3 without the part cooling fan, unless you have rewired the CPU fan. On the stock Ender 3 and Pro and X, the CPU fan is wired to the same place as the part cooling fan, so if you shut off the part cooling fan, it shuts off the CPU fan, and your mainboard can overheat. Rewiring it is simple and fast, and if you'd like to see how, I'll put a card up at the end of this video. If your Ender 3 is still wired as stock, leave your fan on. The print will still turn out pretty good if you follow my other instructions. Lastly, they mention no raft. Now this is not to say that you can't use a raft, it just means that you don't have to. They recommend a brim, and we will print pieces with both just to show you the difference in quality. Notice that they don't give retraction settings anywhere in here, and I know from experience that you're going to want retraction turned on, but let's print a model without it to see why they shouldn't have left out this crucial detail. Now, we have a good starting place for a filament profile. Let's see how it compares to our Technivorous profile. As you can see, I've got it loaded up here. For the first two parts, we'll be using my profile with Cura. The layer height is set to 0.2, which is medium resolution, but will be fine for our purposes. Shell settings are the same as in my other profiles, and so is the infill, the standard 20%. For this model, however, I've chosen to increase the infill to 40% to increase its structural integrity. Next is the temperature. Under the material settings, the profile is set to 240. I did have it turned down here because I was doing a print in my other PETG, which is a little bit lower temperature. But we are going to set it back to 240. And this is the middle of the 230 to 250 range. My build plate is set at 60. And I'm going to increase this for the first print because, as I said, the spool says it should be higher. Now, it's important to remember that you want to go according to the label on the spool. That supersedes any settings you might think you have in your head. They put the most accurate settings for that filament on the spool. Mine says 75 at least for bed temperature, so we're going to go with that. Now, down here in the material settings, you'll see we come to retraction. And we're going to go ahead and turn this off for our first print because I want to show you exactly what happens when you try to print without retraction. So, print speed for the profile is set at 50 millimeters per second. You can see I have mine raised to 80 millimeters per second. Should be well within tolerance. I suggest starting at that 50 millimeters per second to begin with, just so you don't overdo it. You can always turn it up and go a little bit faster. Okay, next is travel. We want combing mode set to not in skin. And I also have it set to avoid printed parts and supports while traveling. This increases print time a little bit, but it's worth the difference in quality and tends not to knock over supports or other pieces. Next we have cooling, and as you can see I have mine turned off. If you haven't rewired your fan, make sure you turn it back on, but you can decrease it to 50%. I tend to use tree supports in Cura, so I'll turn that on as well, and then we're ready to slice our first model. Do need to import it real quick, so bear with me. Build plate adhesion is set to brim. We are going to go ahead and set it to raft for this first model. You can choose raft or brim, or go without. If your bed's not heated, you'll want at least a brim. Alright, so here we have the base of our vise. Now this is actually two pieces and it is one of the larger components in this assembly. I've chosen to run this one without retraction for a simple reason. The other parts in the assembly require dimensional accuracy. They have screw threads and gear wheels and they need to be able to fit together properly. So printing those without retraction is not an option. I'm going to print this piece and show you what a stringy mess it becomes. Let's slice it, jump over to the printer. Pretty nicely, not really having any issues. There is a little bit of blob in the upper right, if you look there. But other than that, everything is going down pretty smooth. As the next layer goes down over the previous one, it tends to flatten everything out, smooth out any defects, and kind of make it a little bit better to deal with. So, we're going to continue printing here. And now that the raft is done, we're on to our first layer. As you can see, there's going to be quite a bit of stringing in here. This is the support structure beginning to form here. And that's probably the best it's going to look throughout the entire print, to be honest. Like I said, I'm expecting some stringing and blobbing, although our outside lines and our shell is looking nice. So we will get good structure. It's just going to be some extra cleanup with this model. Now we're a couple layers in. You can see the stringing a little bit more predominantly, but you can also see that the bottom face is coming out pretty nicely. It's working pretty well. Not really having any issues. It's on to the second part of this component. So this whole first layer is done here on this side. And it looks a little bit choppy. Not bad, just not super smooth. Now this is our support after building up for a while, and as you can see, the model looks decent on the outside. Like I said, the shell is nice, the infill is going down fine, but it's stringing a lot in between those spots where it should be retracting, and that is causing it to stick to our tree supports and gob up, making a sticky mess. This is rather ugly. And here it is in all its disgusting glory. I know this looks bad, guys, but this is exactly why you need to have your retraction settings turned on. So we're going to go ahead and clean this model up, and it does look a little bit better. There's half the mess that I didn't drop on the floor. But the model overall is functional and looks pretty nice. I mean, it would be a little bit better if we didn't have all those hairs hanging off of it, and we didn't have to deal with the retraction settings. Oh, this spot right here, my printer shut off. I had a power outage in the middle of the night. When I turned it back on, it just came out kind of blasé or flat looking, but structurally sound, printed pretty well, and like I said, this is not an ideal piece of PETG. This is a functional piece of PETG, but it's not pretty by any means. Now, I'm going to be doing some welding on this to stick these pieces together after I have the rest of the assembly in here. So I'm not really too worried about the looks of this piece. It's more for structure than function. If we look over here, you can see I'm starting to print my next piece, and it is gorgeous. Okay, tree support is fully structured. There is no stringing going on. Before we jump into this print right here, let's go back and take a look at the settings that I changed in Cura, so you can be sure that you're printing properly, and then we'll take a look at this part, which came out really, really nice, and I think you're going to like it. Okay, so now that we've printed our nice stringy base models, let's go ahead and get rid of this. I'm going to go in and immediately fix my retraction settings. Maybe, for some reason I can't find them right now. Here we go. Turn retraction back on. Go ahead and grab the model here. And we are going to be doing this part. And as you can see, like I said, there are these threads here. Now, I'm going to do tree support with this again. We'll be printing on a raft again because I want a nice smooth bottom. We are going to use retraction this time, and throughout the print, you will see not only a major difference in the tree support buildup, but if we left retraction off, the stringing between these two poles would be ridiculous, and you'll notice that we don't have any of that problem. Let's take a look at the print. Right, and as you can see, our PETG is going down a lot better this time. Now, this is the exact same filament that we used for the other part. We'll see that in a moment when I put the two next to each other. But you're not seeing any stringing, and you'll notice that our build-up structure for our tree support is a lot more uniform and not just a bunch of gobs and hanging there. Now, what happens is the extra filament hanging out of the nozzle, when it doesn't retract, basically scrapes across the top of whatever it crosses next and leaves that chunk of filament on it, and that's why you end up with problems. If it doesn't scrape across anything when it doesn't retract, that's how you end up with stringing. It still has a little piece of filament connecting the two pieces. So what you want to do is set retraction to draw that filament back up in there when it travels, and then start extruding again when it's supposed to extrude, and this eliminates the stringing problems. Look how nice this front edge is here. If you look at the top, you can see I am running a little bit fast speed-wise. I should slow it down. I'm not going to because I have other projects to build, and this is still going to be very structurally sound because I have a high infill rate. So if you look here, you can see that the top of that little piece is finished, and it is pretty smooth. So far, the outer shell of this print is looking amazing. We will take a closer look here in a second, but we got to finish letting it print up. So we are going to continue to keep an eye on it as it builds up. You can see our screws are now going vertical, and as it passes from one to the other, this is an area where you would see a lot of stringing if you were going to get stringing. Looking at it from the front view here, you can see that our tree support is one layer thick and very well built. As we get higher, you can see the tree support has started to grow vertically, but is still very structurally sound. Now we've removed the part from our printer. It is completely done. The screw threads look pretty nice. They are going to need a little bit of cleanup. You want to make sure those are dimensionally accurate, but the overall shell of the actual model itself is pretty gorgeous. So at this point, what I'm going to do is I'm going to remove the support, and I'm going to put this up next to the other assembly, and we'll compare the two shells so you can decide. Obviously, with retraction, the print is a lot better, but it's something that I think you need to see side by side to understand that there is such a big difference. Now, as I put these two pieces together, notice the stark contrast in finish, surface finish. The part we printed with retraction is very smooth. It doesn't have these white, chunky pieces, and the layer lines are slightly less visible as well. So overall, it is a way better model. You can take it out of here, you can get a little bit better look. Look how smooth that surface is. Now this here is the bottom surface that was in contact with the raft, and it does look pretty identical to the no retraction print, but this top surface is way different. Now this is the layer lines as you see building up. It is a lot smoother, and you can see the dimensional accuracy on my screw threads here are pretty good. And for the flywheel and the knob, I am using the exact same settings as in the last print, except I have lowered the temperature for this guy because it is slightly opaque and requires a little bit lower temperature, and we're running at 220, and I know that's below the recommended threshold of 230, but this has very PLA-like qualities and prints really well at this temperature. Alright, now for the final pieces. These are going to be the plates that go on the sliding part of the vise and the stationary part of the vise. We're going to jump over to PrusaSlicer. So I have my two front plates in here. We're going to go over a couple of settings, and we will run a print in PrusaSlicer to show you how to print quality PETG there as well. So you can see I've got my models placed on my build plate, oriented, separated a little bit. We're going to make sure I have the proper printer selected, which is my Creality Ender 3, and I also need to adjust my filament. We're going to go with one of these generic, I think, where's the Prusa down here? Filament PETG. And we'll just make sure everything's set up right. So that should be pretty close. Now we need to make sure we have our brim turned off, because I told you we were going to print without it. Actually, we'll print with a brim. We don't need to print any without adhesion. We'll print with a brim on this one to show you the difference between that and a raft. And then we'll go into our print settings. You can take a look around. We'll leave our layer height the same, so it's pretty similar to the Cura profile. Parameters the same as well. Just checking a couple extra settings here. I do need to go in and, okay, infill, I don't need 100%. Well, these are going to be pressed up against pieces, so I could leave it at 100%, but we're going to take it down to 50. And then, yeah, infill, everything's looking good speed-wise. So skirt, we're going to leave that exactly how it is because we're running our brim. You can see our brim width here. Support material, won't need any for this. We are going to change some speeds. We will lower them a little bit. I lower them in PrusaSlicer because its accuracy is amazing. It does really well as far as slicing, but I feel like I get a little bit better print when I slow down the speed. Although, ironically, I get a little bit faster print time using the same print speed from PrusaSlicer than I do from Cura. So let's find retraction. We need to make sure that it's on. Nope. We'll take our bed temperature down. Make sure that it's printing at that temperature at all layers. And same with the bed. We want to make sure that that's adjusted properly. Now, I did bring this up to 70, 75-ish. We're going to be printing with our eSun PLA, and it's a little finicky. It doesn't have the nice labeling things that the other PETG has, but and here we go. Part cooling, we're going to turn that off. And it looks like that should be most of our settings, except for retraction. So retraction is on. We save our settings. We are going to slice up this model here. Again, make sure we have our proper printer selected. And we can hit slice. So let's do that. Alright, fairly simple model, shouldn't take too long to print. Let's jump right into it and we'll see how it comes out printing PETG with PrusaSlicer. So you can see our print starting to go down here. This is the PrusaSlicer print. It is going to look a little bit different than the initial prints with the other slicer. So this is eSun PETG. This stuff is beautiful. You can see it has a very gorgeous sheen to it and a very smooth outside. So We're going to continue just watching this to build up for a minute. The infill looks slightly different as well, but overall this is going to come out as a nice print. You can see it is looking very gorgeous. The sides are clean. There's a little bit of marring on the inside back there where I think I need to return the retraction settings up just a little bit because I have it set at 5 millimeters. It should be at 6. So other than that, that's the inside of the plate, and when I'm done with it, that will scrape I'll scrape off. You won't see any of that anyway. So we're going to continue rolling with it for now, and I am very pleased with the overall look. And as it pulls our plates forward here, we can take them off the bed and get a little bit better look. Now the brim comes right off. You can see a little bit of that red PETG left in the purge line, but that is a very, very nice finish. There's a little bit of cleanup left to do, but not nearly as much as the first model we printed. So I know our settings are pretty close. Now look at this. I've got them all cleaned up here, and this is gorgeous. These little V slots right here should slide right into my model.
So now let's get a look at our fully completed
go.
assembly. As you can see, our vise is gripping something, and I'm trying to turn this block in here, and it is pretty tight. So let's back it up a little bit. It does move very slowly because of the threading, and then I turned it there. And again, it's super stiff, so it's very, very effective. It's pretty nice looking. As you can see, this is the same as this piece, and these are the pieces that were printed without retraction, so they look a little bit rougher. This surface here is smooth and gorgeous, as well as the inner surfaces of both of these plates. The knobs, I knew were going to come out fine because, like I said, that PETG, being opaque as it is, has very PLA-like qualities. Although they were printed at the exact same settings as this, just about 20 degrees lower. Let's flip it over and look at the bottom here, because this piece is where it really shines. You can see the contrast between the retraction and the no retraction. Now, those lines you see through there, that is actually my infill. It is because of the transparent nature of PETG. If you were to want to get rid of that grid pattern, you would need to either use something a little bit more opaque or put quite a few more shell layers on there. So this runs pretty well. It is pretty heavy, so it kind of holds itself still. I can open this up to drop that block just to show you that it is functional and actually relatively strong. So we learned how to print some PETG today. I showed you all the settings you're going to need to know to print it in Cura as well as in PrusaSlicer. Like I said, this model is not the best when it comes to the frame, but the rest of it turned out quite exquisite. I didn't bother with printing these little clips that you'll find in the thing that go through there, and they come in both sides and kind of connect and clamp it together. What I did instead was I kind of welded it together, because I felt like that would be a little bit better than fiddling with those. They were a little bit tricky to get in. So overall, a very, very nice PETG print. This whole assembly is done in 3 different kinds of PETG using 2 different slicers, and I think it is overall a great success. So if you have any more questions about PETG, let me know. I will be doing another video shortly here in the future where I will be printing 2 of these. And we're going to make them out of TPU because I think that will give us a little bit better clamping power without damaging either the component or the piece that we're trying to clamp down on. But for now, very successful foray into PETG printing, and I hope you learned something. Like I said, the most important setting is that retraction setting, and then making sure you have your filament temperature up high enough. Like I said, if you go to that website, it specifically says to turn it up to the point where your filament is browning and then turn it down a couple degrees. So you want this as hot as you can possibly get it without burning the filament. If you burn the filament too much, it will clog the hot end and you're going to have a bad time. Sorry, I couldn't resist the South Park reference. Anyway, the next video I think we'll do on another kind of plastic. Let me know if you want to see TPU or ABS first, but this was a very, very fun build, and this is going to come in handy for holding down parts. As always, this channel is brought to you by these fine Patreon supporters. If you'd like to support the channel on Patreon, head over to www.patreon.com/Technivorous. Alright guys, that's going to be the end of this video. As always, thank you. I'll put a video up right here that you can check out for more of our stuff. And if you're still here and you haven't already, why don't you click right here and subscribe to the channel.